Hello.
Good evening.
Hello, Professor.
Hello. How are you?
I'm hanging in there.
Miss Ford, Happy New Year to you. Sorry, Happy birthday to you.
Oh, I'm going to Happy New Year. Thank you.
Welcome. I so I
Thank-
just I just read your email a few minutes ago, and I responded to that.
And I responded back before you let me in.
Oh, you did?
Uh-huh.
Okay.
So, and I look at your BCCC email.
Yeah.
And
Okay.
excuse me.
So, can you mute yourself, Miss Ford?
Yeah.
Okay. Now today, this week you have a lot of work this week because next week is the final week. As a matter of fact, let me see. This is okay. Yeah, next week is the final week. After next week, it will be a final exam. So I have some more assignment for you. The Excel assignment is usually not that difficult. It makes it faster, you know. And I want to show you something more about the project. At the end of the project is located here. Your course is this one here. Okay, and this is your project. Okay, let's see assignment. You can click on assignment. Then you can scroll down and you will see a project right here. So your project is they're all these Excel assignments together are part of the project. But this is the main project here. This is the data set you use for the project. It's right here. So what you're gonna do is to type these numbers in the Excel and then use it to answer the questions in the project. So be careful so you don't miss a number. Type it, and then you put in the project. Now, some people ask me, how do we put Excel work inside a project? How do we do that? Well, I can show you now. Suppose that this is the project. What is the project? Right. I think I'm gonna move this so that they'll be together. Now, this is one that you're gonna do. It is due on August 15. Okay. I think this is it right here. Yep. So this is the project right here. So if you click on it, let's say that you want to upload, to paste.
It says it's locked for me.
No, it's not. Maybe you click on the wrong one. There are two of them. Let me look at it. This is the project. I just opened it. Now, let me go back to it. What is it? I think it should be here.
Okay, it's not locked anymore.
It's not locked. So now, see, now you can type in, it's Word document, so you can type in and then copy this. Now, if you like, you can put this.
Oh, I'm sorry to interrupt. Actually, when you click on the file, it says this file is currently locked.
Yeah. Let me look at it and see why it is saying that.
Okay.
It shouldn't be saying that because it is open now. Okay, I gotta close this. So I have right. I gotta close more things.
Yeah, that file won't come up. It says it's locked.
I have enough
It say the same thing.
right now. Some things are blocking me from getting back to it, so I may have to close some things more. What should I close now? Okay, I know what I'm going to do. This is it right here. I'll share it now. So we go back there, assignments. It shouldn't be locked because I published it. This is the project here.
And click on it, and when you click on the file,
It's locked. So let me click on it. And then edit. See, let me see why it's saying that. Edit. It shouldn't be locked. Okay, it's due. This is due date.
you should make it like available from today.
But it shouldn't be. I don't know. Once they make it due date, it shouldn't be saying that. But let's try it and see what if it works. Okay. Now try it again.
Okay.
Professor, this one went to Excel.
It still says it's locked for me.
Still locked. In that case, let's try the other one then. I can do this. Project.
That's the data set project.
Oh, but I'll take care of it now. Let's see. Did you click on this one? When you go, did you click on this link here? This thing here?
Yep, that's the link I clicked on. It says this file is
Oh, now it opened. Now, which one you on, Professor? Is it data set for statistic project?
Just hold on. Let me fix the problem.
Because I have that one.
Close.
What the hell is going on right there?
See. Now we're gonna go back.
the background really
Then take this off. And then make this one available.
I think that's the right one.
Project. Okay, make it available to July 15, August 15. So make it edit. August 15. Get back to 40 points. 40 should be enough. Okay, project points. You can text. Then do. Okay, I'm gonna make this. August 15th gonna be due. Available today. Okay, August 15th. Okay. Now I'm gonna save this and publish it. Now check it again.
Okay. And I'm gonna refresh my page as well.
Yeah, refresh the page. So Miss refresh the page your own and then check it again.
Professor is still not working.
Working this time.
Like I see the next steps and stuff like that. I can start assignment, but when I click on the open the file, Matt 107 course project,
Yeah.
I'm not able to open it. It says this file is locked.
Okay, you know what I'm going to do? I'm going to make it unavailable and create a new one, a fresh one. Okay?
Okay.
This
Thank
one
you.
will work. This one will work. Okay. Okay, projects. Okay. Projects. Work here. Okay. Okay, this file, I'm gonna put my own file there. Okay. Now I'm gonna put this file. Upload document. Actually, matter of fact, I'm gonna go from here. All right. Document. Course document. Okay. Then I'm going for projects. Projects. Interesting. Load more. I want more. So I'm gonna go down so until I see the projects. And P. P value projects. Okay, I'm gonna load more. Okay. Just 1 minute. Okay. All right. So what I'm gonna do now is again copy this. Assignment. Project questions. Course project. Save as. Okay, statistics project. Project. Yeah, I'm gonna save it on my flash drive. Okay. And also in my desktop. Then I'll upload it.
Okay, because I was getting ready to say data set for projects is the only one in the
Yeah, that one is the only one there now, but I'm gonna upload this one now.
okay.
Right. Now I'm going to close it. Then go back to our page. Okay. I think I'm going to close more things. This is where we are. Okay. Course files. Upload statistic projects. Statistics projects. Okay, let's see right there. I think it's uploaded now. So we'll open this. And then we can go back to our open too many things. I'm gonna close this. Okay. You can see the screen now, right?
Yeah.
So I'm gonna go back to assignments. Okay. And create a new project. Okay, project. Project. Upload your work. Yeah. Okay. This one. Then insert my own course documents. So I'm gonna look for statistics project. Okay.
That means there's too many in there.
Yeah, I'm gonna choose, just find the one that is for the project. Let me search for it, statistics. Okay. Statistics project. Project. Yeah, I just uploaded it here. Anyway. Date added today. Okay, I think I added data set for project instead of project. Fine. Statistics project. Right here. Instead of adding it, it's opening it. Okay, I'm gonna go from here. Okay. Now it added it now. You just added it now. You didn't add it before.
I'm gonna look at it.
Yeah. So that's why. Now I'm going to go back. And the assignments. Okay. Create the assignments. Project. Okay. Upload your work here. Okay. This one, the one that say it is locked. So I'm gonna insert this. Insert. Cross document. Right here. So I'm gonna put it. It's not uploaded. So I'm gonna make it project. Okay. Due. I created this one by myself, so you shouldn't have problem by it. Save and publish. So if you try it now, it should be available. If you're not available, then I'll work on it again after the class. Let me make sure there's not right here. This one is out. This one is out. This is the project. This is what you're gonna do. So I'm gonna move it closer to the data set. Project. This is the data set for project. And this is Excel assignment. Yep. So it should be now. If it's not, that means you have to check your computer. Now I just created a new one.
Is the course project?
So let us begin now. So when you go to project, you can copy when you do something in Excel, you can copy it and paste it. When you finish doing the work on Excel, you can copy it and paste it on the Word before you upload it. Okay. So today we're doing something new, confidence intervals. You can see the screen now, right? You can see the screen. Let's begin. Confidence interval. Now, yes. Confidence interval gives the estimated range of values.
I'm sorry. Can Ms. Ford please mute?
Huh?
Okay, thank you.
So confidence interval simply means the estimated range of values that is likely to contain a population parameter. When we say population parameter, we are referring to things like population parameters, mean, which we can present with the symbol mu in Greek. It's a Greek word, Greek letter, I mean to say, mu. We can have the proportion, the percent proportion. If you can use P to present, or you can have things like variance or standard, maybe standard deviation is better. standard deviation, which can be represented by the symbol. All these things are called the population parameters because they give us the numerical estimate of what the population is. So a confidence interval is the estimated range of values that will contain this population parameter. I have it for the entire population. So you can use it to estimate these parameters for the population. For example, the confidence interval for the mean is a way of estimating the true mean. You know, instead of using a single number, we use a range. So now, let's start with this concept, point estimate. When we say point estimate, we are referring to a single numerical estimate of the population parameter. For example, we can say that a local bus driver can say that the average price of gas in 2008 is $2.34. So you see one number, which is only this.
What about the 2018, Professor?
What's that?
What about the 2018, Professor? That's a number too.
Number 2?
I said, what about the 2018, Professor? That's a number too.
Oh.
I'm joking, you know.
I know. So, you know, it's a single number. Now, the best point estimate of the population mean is the sample mean. That's the mean you get from the sample. You give you the best estimate of the population parameter, you know. Now, for CEO or any company, let's say, you know, last year we have this COVID-19 thing, and then a lot of places closed up, you know. We can say that the average sales in grocery stores declined by 20%, one number. See? So that's the point. That's why you call it point estimate, because it is only one number. The one we are focusing our attention today is the interval estimate, which gives us a range. For example, the same bus driver can say that the average price of gas in 2018 is between $2 to $3 a gallon. See, this is better because it gives you a range, which the mean will fall. I can say that the sales decline by between 10 to 20% last year because of the COVID-19. See, that's two numbers, range. So that's why I call it an interval. So it's a range. So confidence level, the other term we're going to examine here is what we call confidence level, which means the likelihood that the true population parameter will lie within the given range. Usually in statistics, we have three most popular confidence level: 90% confidence level, 95% confidence level, and 99% confidence level. And you remember when the vaccine came out, I think they said that the Moderna can prevent COVID-19 95% of the time. I think that's what they said. That is the confident. They are 95% confident that this vaccine can prevent COVID-19 infection.
I don't know now with the Delta virus, but yeah, back then for sure.
It can still prevent it. You know why I say that?
Why?
If you have the vaccine, you might still get it, but you might not be sick. You know,
that's true, but like now they're talking about how the Pfizer vaccine is only going to cover 60%, and back then it was 95 or 99.
Oh yeah,
yeah. Because
how about the Moderna that we want that people? The own is still the same, I think, right?
I'm not sure about that one. I only heard about the Pfizer. So
if they say 60%, that means they are 60% confident that it will prevent it. Now remember that you have a vaccine doesn't mean that the virus or bacteria cannot. Actually, the vaccine is usually for viruses, that the virus cannot infect you. It doesn't mean that it can still infect you, but the damage it will cause will be minimal. compared to when you don't have the vaccine. I'll give you an example. When it is raining, if it is raining and you want to go out, you put on a raincoat. That doesn't mean that water will not touch you. Water will still touch you, but it is little compared to somebody who doesn't have a raincoat. You see what I mean?
Yeah.
Yeah, you know. Now, so these are the most common we have, but most pharmaceutical industry have to be 99% confident that they're or even 95 that the medicine they are making can protect us from the disease or cure the diseases. We have 90%. So if you say 90% confidence level, if you're in 90% confidence, that means you're 90% confident that what you are saying is true, about the claim you're making is true. If you look at the penal, the criminal justice system, somebody can be on a death row for like 10 years. You know what I mean? 10 years, even 20 years, because they want to be sure that this is actually the person that committed a crime. You don't want to execute the wrong person. So they have to be 110% confident, but we don't have that in statistics. As so many DNA tests are showing now that many people were convicted wrongly because of, and that's why they like to delay that death penalty. Make sure that you're not punishing the wrong person for the thing. Anyway, so that's the three most common confidence level we have. There are other confidence levels. You can be 98%, you can be 99%. The first thing I want to show you is how to get a critical value when you have this confidence level. So let's say that I have them here already. 90% confidence level. If you say that you're 90% confident, so your chance of being wrong is 10%. See? So how do you get this critical value? We call it Z alpha over 2. Why alpha over 2? Because remember, it is two numbers, two sides, left side and right side. So there are ways you can get it, but there's a shortcut method that I developed that you can use that will get it faster for you. Remember, I told you to print this table, statistical table, and keep it handy. Now this will help us in finding the alpha level, the critical value. Okay. Now let's do one example here. It says here, find the critical value Z alpha over 2 corresponding to 95% confidence level. The shortcut formula that I use for it, let me write it down and then bring it here. I'll take you to the other books workbook. So Z alpha over 2 become Z alpha over 2. I'm gonna make it from here. Z alpha over 2. Okay. Equals this is alpha, right? Let me see if I can get the alpha. Okay. Alpha over 2. Let me use this as alpha. But 2 will be equals P over 200. So that's what we'll be using. That's the formula that will give you a shortcut to it. P over 200. Okay. Solution P over 200. Why P over 2? Percent is P over 100. But this time around, we have two sides, left side and right side. So 100, 100, 200. So P over 200. And let me show you how this works. It says, find the critical value of Z alpha over 2 corresponding to 95% confidence level. So you're going to write Z alpha over 2, alpha over 2 equals P over 100. He said for 95%, yeah, P is 95. So you're going to be 95 over 200. Okay. Now you can do this on the calculator. 95 by 200. 95 by 200. 0.475. Because the numbers in that table is for these decimal places. So you can make 0.4750. 0.4750. 0.4750. Now you go to this table of normal distribution and look for this 0.4750. So this is the table right here. Look for 4750. If you don't see it, you use the one that is closest to it. But I can see it right here. I can see right here. This is it right here. You follow it to the left. 1.96. 1.96. So the answer for the critical value becomes 1.96. 1.96. And you can see it right here. Have it on the teacher. You can see 1.96 right here. See? Any question?
Nope, I think that's dope.
So when we start doing test of hypothesis, so if it is two tail tests, you can use this method. For one tail test, you cannot use this method.
Can you enlarge it a little bit, Professor, so I can write it down?
Say again?
Can you enlarge your
Oh,
solution?
enlarge it.
Yeah, it's small. Thank you.
Are you sharing this on the Canvas, this Word document?
No, but with the video, I will share the video. Why? Because the Word document itself is not this solving. You see only the question. You already have it in Canvas in the files, but it has mainly the question, not the solution.
Right.
So the video is what I'm gonna upload so you can watch the video again.
Right. I got you. Thank you.
And let's try it again for another example. Look at this one, 99%, right? Solution. It says find the 99% confidence level. That is the critical value. Okay. Again, remember the formula P over 100. So Z alpha over 2 equals
99 divided by 200.
exactly 99 over 200. 99 by 200. Let's see. Take you to Desmos calculator. 99, but change this to 99. 0.495. Now, because those numbers in the table are 4 digits, so you can make 0.4950. 0.4950. 0.4950. So you gotta look for this on the table. 0.495. If you don't see it, you look for a number that is closest to it. 4950, right? I got 4949. Can you see that?
Yeah, also you can use the Control F and then like just type it in and then it will show you like the closest or the exact number.
Good. That's a good example. Yeah, that means Control F, right?
Yep.
0.4950 is not there, so it won't show you, but it will show you number. See, this number is closest to it. But there are two of them closest to it. This is 4949. If you ignore the decimal point, 4950 minus this one here will give you 1. Let me show you. 4950. Okay.
If you just do point and not the 0, it should show you the closest number because it worked for me. I'm not sure though.
It will work for you, but it will give you 0001. See, which is still the same thing. Am I right? See,
Yep.
1. See, 1. And if you try the other one, which is from which is ignoring the decimal points. If for 4945. So if you put decimal point, you're gonna give you 0001, which is still good, but it might confuse some people. So that's why I say forget about decimal point for now and just put numbers. So you can see 4951. Let's try it. 4951. 4951 minus 4950 is to give you 1. So they are equally close. So there are two of them that are closest to it. What you going when it happened that way, what you're gonna use to use the bigger one of these two. See, I'm gonna use this one, and if you follow it to the left, you can see that it is 2.5. If you go up 8, 2.58. So you're gonna be 2.58. 2.58. What is it? What is it? Where are we? What are we? 2.58. 2.58. Which you can see right here. You can see 2.58. Now this one, 2.575, you can get it, they get it by getting the numbers for two of them and getting their average. That will give you 2.575, which is still gonna round up to 2.58. So when you are solving an equation and they give you a confidence level that you don't know the critical value, this is how you can carry it to find it. But most time they give you the one that they give you 90%, 95%, and those values are already in the table. For example, for the 90%, 95%, you can see them right here. If you go to the next next two tables, you can see them here. See, because this table here, you can see it for 75%, see the critical value, 1.15. For 80%, 1.28. For 90, 1.645, which is 1.65. For 95%, 1.96. For 99, that's the one we just calculated, 2.58. See, they are there already. So we can pick them. If the equation give you one that has a critical value, you can just pick them up from there. Excuse me. But if they give you the one that the critical value is not there, then you use the formula that I gave you to find the critical value. Questions?
I don't understand what you just said.
What I'm saying that if they, so let's say that the question gave you this, they gave you a question, but they didn't give you 95%.
Right.
They say they can say 82%, which is not in this table.
Right.
So that means you can find it using this formula that I showed you, the method I just explained.
Right. I got you. Thank
but
you.
if they give you the one that is on the table, you can just go there and pick it up.
Okay.
To solve your problem. Yeah. So now, remember that the best point estimate of the population mean is the sample mean. Now let's solve an example here. It says a sample of reading scores of 35 fifth graders has a mean of 82. The standard deviation of the population is 15. Find the best point estimate for the mean. Find 95% confidence interval for the mean reading scores of all fifth graders. Then find 99% confidence interval of the mean reading scores of all fifth graders. Now, let's start with the first one. It says find the best point estimate of the mean. Okay, solution. This statement says the best point estimate of the population mean is the sample mean. And that's what the statement said. But this question now says a sample of reading scores of 35 fifth graders has a mean of 82. So this is the mean of the sample. So that the best point estimate here becomes the sample mean. That's the mean. The answer becomes 82. Sample mean of let me put it in symbol because there's a way we write sample mean. The sample mean is written in this form. I will take you to the other workbook so we can get this character for sample mean. Okay, this is the character for me. What to use to get the character for the sample mean. So X bar equals 82. That answers that question. Because if that statement said that the best point estimate or the population mean is the sample mean of 82. See? Answer becomes this. 82. For B, sorry, for A. Now B says find the 95% confidence interval of the mean. To find that, you need to do it might involve the 5 steps. Let's say the first step is to, first of all, let's to list the values we have. Solution. Yeah. Now, first of all, we have it said a sample of this course of 35 fifth graders. So our sample is 35. Sample size is 35. And it says has a mean of 82. The mean of 82. I mean sample mean of 82. Okay. Copy it and put this here. See? Then the standard deviation of the population is 15. Standard deviation is 15. So you put the standard deviation as 15. Excuse me. Yep, 15. Here equals 15. You always change that symbol when I'm doing work like this. Okay. Then it says find the 95% confidence level interval for the mean. So our Z alpha over 2, Z alpha over, that's critical value, alpha over 2, we have it already for 95%, alpha over 2, for 95%, we have it here on the table as, for 95%, it is 1.96. So we have to put 1.96 here. 1.96. Now with this is the first step.
I apologize. The 1.96 you got from the 95%, right? Confidence level. Okay, I got you.
Now, this is the first step to list them out. Second step is to calculate the error margin. Excuse me. So the error margin, the formula is, for error margin is this. Once you calculate the error margin, you're almost done. All you have to do then is to subtract the error margin on the left side, then add the error margin on the right side. And that's it to get your confidence interval. So the error margin E, error margin E will be, our formula is this. Okay. We have Z alpha over 2. We got Z alpha over 2. Our alpha is right here over 2. Okay. Times standard deviation divided by the square root of n. Let's find the standard deviation first. Divided by square root of n. Okay. N. See, that's the formula for it. So I'm gonna copy it. Matter of fact, maybe make it bold so we can, because it's a formula. Copy it and then paste it here.
So the OC, or like, I think that's what it says, that's the alpha, right?
Alpha, yeah.
And what does that represent?
Alpha over 2 is right here. Z alpha over C. Z alpha over 2 is, we have it 1.96.
Oh, okay.
Yeah. So once you plug this in the number, let me write this down so we can plug them in. Our sample size was 35. Our sample mean is 82. And the standard deviation is 15. Z alpha over 2 is 1.96. 1.96 for the 95% confidence. So let's go and plug this in and get our results. So we have which give us equals Z alpha over 2. We'll get it at 1.96. 1.96 times we have the standard deviation of 15 divided by square root of n
35.
sample size is 35, right?
Yep.
35. So let us get this on the calculator and put them answer in. So we have this from our calculator. Have okay. The alpha was just 1.96 times standard deviation of 15 divided by square root of n, which is 35. Okay. That gives us 4.97. If you run the 4.97, because it gave you 4.9695. So we round it to 2 decimal places. 4.97. And that's what it is right here. So I'm going to put it here 4.97. 4.97. See? So you can copy this and put it on the main workbook. So we have it right here. 4.97. So now we have our error. How many? Now the confidence interval is very easy now. Remember it says find 95% confidence interval. So once you have all this and get the error margin, then the 95% 95% confidence interval is you have X bar minus error. I'm gonna get it from the main book because the character for S bar is not here. So S bar minus this error. On the left side, you subtract the error. You know, on the right side, you add the error. Less than the mean, which is what we are trying to estimate the mean. And then less than X bar, which is this. Okay. S bar plus error. So I'm going to copy this. That's how we get the confidence interval. So this is what we are actually trying to estimate. We are trying to estimate this population mean of mu. This is what we are trying to estimate here, right here. We are trying to estimate it using the sample mean. So that means S bar minus our S bar is 82. That's sample mean 82 minus error of 4.97. 97 less than the mean we are trying to estimate. Then less than 482 plus 4.97. So in this side, you subtract it, in this side, add it, which give us in the decimals 82 minus 4.97, 82 minus 4.97 give us 77.03. Have 77.03. 77.03 is less than the mean. Less than the mean. Less than. Okay. Now on this side you add 82 plus 4.97. Let's go and check it. 82, just turn it to plus sign. So it's minus sign, let's turn it to plus sign, see what it gives us. 86.97. It gives us 86.97. 86.97. So conclusion, of course, you have to conclude. Now, you mean that the average score is between 77.03 and 86.97 for the population. So we can say with 95% confidence that the mean reading scores of all fifth graders, the mean reading scores of all fifth graders rise between 77.03 and 86.97. See? Question? Question? Hello?
No
No
question.
questions.
Okay, good. Sometimes they will not give you the mean and standard deviation like this. I think this is the way you do it. The last, your last Excel assignment that I just put in. I think it's Excel assignment 4 or 5. Hold on. Let me think. I think it's Excel assignment 5. I put it last. Yeah. Excel assignment 4. That way they give you numbers. If it's like here, if you look at this one, here, it said they didn't give you the mean. So that means you have to get it by yourself. And that is basically what you see in the Excel assignment 4 about confidence interval. So you say a random sample of number of farms in thousands in various states are as follows. You say estimate the mean number of farms per state with 95% confidence. So in this case, what you're gonna do is to use Excel. Excel will give you the mean, and then of course they give you the standard deviation. And Excel will also give you the error margin. So all you have to do is to subtract on the left side, excuse me, and add on the left side. Let's try it. You ready? Are you ready for me? You're not ready, huh?
Yes,
Yes, we're ready.
Okay, let's see. How many of you will be awake? You know. So of course, the first thing is to enter this in Excel. All the data values in Excel. So I did that. I think I have it here. Let's see. See, it's in Excel. So I'm gonna remove this serial number. Well, it's good because they say that n, from here we can know that n is 31. Yeah. All right, although I think Excel will give you that one too. So let me see. I'm gonna remove this. Okay. All right. So you can see that this is 47. Let me make it a little bit bigger. This is 47, right? And the one you have, you can see that the first number there is 47. See, 47, and so on and so forth. So now, what you're gonna do is to see data analysis. Okay. Let me close this. Let me move this to our side so we can see this one. Okay. Now click on data and then data analysis. Then you can now choose descriptive statistics. Okay. Now, the input range, okay, will be here, confidence interval, all the way to the, okay, last digit. Then, of course, you said you want the summary statistics, and so that you can get the mean. Of course, you have to check label because we added the label. Then confidence level. This one, oh, this one is 90%, right? I think they say 90%. Let me see. The question says, use 90% confidence. So we're gonna change that to 90% confidence. So we're gonna click here and change it to 90%. Oh, I think I click on something. Can you see the screen?
No, we cannot see your screen.
No, I can't see your screen.
I think I click on something and they okay, click and share. Can you see it now? How about now?
Yes.
Yes, we can see it now.
Then, so I click on this, then change this to 90 because it said 90. 90.
What is this, in Excel?
Yeah.
Okay.
Okay, let me start because let me start all over on that.
Okay.
I know some of you get confused already. Okay, you ready? You can see the Excel screen.
No, we can't. We gotta share it first.
Let me share it again. But now,
Yes, we can see it now.
so let's click on data, then data analysis. So you can see, then choose descriptive statistics. Click OK. Now for the input range.
So you click on what if analysis, right?
No, just
I think I
data.
missed something. I apologize.
Yeah, okay.
Go 2 steps back.
Let me close everything then. Now, but you can see the screen though, right?
Yes. Okay. Go ahead.
Now, the numbers are in already. So see, let me start from the home. Now, you gotta click on data.
Mm-hmm.
Then data analysis.
Okay.
If you don't have this on your Excel, that means you have to add it, use add-in.
Oh, I tried doing that. It didn't pop up on my Excel. So
What are you using, laptop or
I'm using my computer.
So you should. So if you click on this thing, you have to add. It doesn't come. It comes, but it doesn't show until you add it from
What?
Excel. You gotta go to file and then to options. Then from options, you can choose depending on the version of Excel you're using. You can
They
choose the
definitely
add-in.
don't give me all that, but okay.
You know what you're gonna do, yeah? You know what you're gonna do, since I don't know the version you are using of Windows you're using. So you gotta do is if you know the version, go to YouTube and type in how to put add-in in your Excel.
Okay.
Then in that version of computer you're using, it will give you the video for that.
Okay, thank you.
You're welcome. So when you click on that, and then you click data analysis, and then choose descriptive statistics, and then OK. Now we start from here and then highlight from all the way down to the last digits. Okay. Now, because you clicked on this title, so you gotta check label. Check label. Then check summary statistics. Now you're looking for confidence interval. Check this. So then after you check it, you change this to 90. But say 90. We're looking for 90% confidence level. Then the output range is where you want your output to be. So click on it, and then for me, I can choose my output to be here. Okay. Then you click OK to give you the output for all of them, everything.
Wow.
So here. You can get output.
Why didn't you teach us this way before? This could have been so helpful.
I did. I thought I did. Remember, I did many
You know
examples
how
on
you know
Excel.
how long I took to find a standard deviation and variance? You know how long it took, and I
That is
find
not.
out real-
You didn't miss anything. Believe me. That is not a waste. That is not a wasted knowledge. For you to know how to get it, you know, it's good.
one of my Alex said I spent 302 hours in it on the homework. I was like, what?
Oh, good, good. That means you are getting you're getting the right you're getting what you are paying for this class. You know what I mean?
I
Yours
guess.
said 3, mine said 6. Shit.
Damn, girl. I got 100%, so whatever. It's worth it.
You're getting the value of your value for your money. Okay. So you can see it shows you the count. N is 31. Now, see, it gave you the most important thing that it gave you the error margin. So you don't have to start doing N, X bar. So what you have to do now is to do this part of the work. Just confidence, see 90%, you can see the error margin, excuse me. And the, let me highlight it. So anyway, this is the Excel assignment 4. So this is what you're gonna do on that.
Is there a command way, or do you have to do it through data analysis?
I don't really, I'm not sure there's a single command to do this.
Right.
Because it involves many steps. So
Right.
the best thing is to see how you can do it. See if you can do that adding, it will give you the link for that data analysis. That makes your life very easy, believe me.
Yeah.
Now, so you have the confidence level, and it gave us the mean. See? Okay. Now, you can see the standard deviation it gave us on the paper is approximately 31. You can see it on the question here as 31 approximately. You can see it right there. You give it approximately 31. So now, all we have to do now is to you can see the screen, right?
Yeah.
So all we have to do now is to copy this. Copy this because it gave us the error margin already. Copy this, and then we're looking for the 90% confidence level. So change it to 90%. S bar minus error less than mean, less than S bar, and our mean in this case. Let me put the mean. Our mean is 43.45. Let me write it down so you don't forget. 43.45. 43.45 is the mean. Yep. So then I can just take you to the this place and find the character for the sample mean. So in that case, our sample mean in this case becomes 43.45. Okay. 43.45. We have it right here. 43.45. See? That's what I mean. So now our error, which we got from Excel says that our error is 9.53. That's right here, 9.53. So error is 9.53. So we got it as 9.53. 9.53. So that's what you're gonna do is to subtract this number on the left side and add on the right side. So that which means S bar is 43.45, 43.45 minus error of 9.53 is less than the mean. Excuse me, the alpha. Less than the mean. And then less than, okay, 43 0.45 plus the error of 9.53. So 43.45 and 9.53. Okay. I'll take you to the calculator now. Let's do it. So you got 43.45 minus 9.53. Give me 33.92. 33.92. Less than the mean. And of course, less than. Okay. Less than. On this side, we add it. So 43.45 plus 9.53. You go to here, then change it to plus. See? Excuse me. 52.98. 52.98. Okay. 52.98. So in some books, they might write it in this form. 33.92, comma, 52.98. They mean the same thing. So that means it goes from between this and that. Conclusion. Can anybody help us to conclude this? Can any of you help us to conclude this?
We could say, go back to the question. What was the question?
Okay. Right here.
The confidence level for farms per state. I don't know what you did. I forgot, but it's something like that.
So you can say yes. It's a good.
It's between,
you made a good attempt. We can say with 90% confidence that the number of farms
is between,
or we can say that. Okay, we can say with confidence that each state have on average 33.92 thousand to 52.98 thousand farms. See?
Yep.
Or we can say we can be 90% confident. We can say with 90% confidence. Okay, that each state have on average, make sure you put the average. Average is very important. Without average, you cannot get full point because it is the average you are trying to estimate here. So you have on average between 33.92, sorry, 92 to 52.98 thousand. Okay. Farms. See? Got it?
yep, thank you.
So tomorrow we look at how to calculate the minimum sample size. Minimum sample size. Okay. All right. I see it. Is there any question before we leave?
Let me check if the test works.
Thanks.
I have a question.
Sure.
So my question is similar to the question that Marche asked the other day. So as I was pulling out my hair doing the homework, I guess my first question is when to know to use the formulas, as she was asking, because sometimes, I was going through the problems and I think I got it. And then it's like, I had to go and look for the explanation because I was not able to tell what the you know, I just wasn't able to use the formula. And then some of the formulas were not the same. So like for the Z intervals, defining the Z, we used it was 0.5000, and you subtracted when finding.
If it's on the tail, remember I showed you a diagram, and I said if you're using my table, it's not the same because it is for each first need to draw the diagram. Once you draw the diagram, then you can now see the direction to go, whether you're going to subtract or not, and make sure that you're using the table like this table that I will use in the class. That way. If you're using a different table, that table might have a different rule. So that's why I recommend you use the one we use in the class. So, like for example, I mentioned that equation. Say, let me see what I'm going to do from here.
Well, the homework, they always subtracted or added by the 1.000.
They are using a different table, remember? So if you're using a different table, that means that is the rule for that table. If you're using the table we use in the class, and if you use it well, you will get the same answer. So if you're using the table they used in the homework, and if you know how to use that particular table, that one is the cumulative type, then you can use subtract from 1, and but our own, the one that I showed you, even we use it today as well. That one you don't have to go all the way to 1, because that one is not cumulative, and but it's still symmetric. The statistical table, that's this one here.
Well, I guess this one here. The one for the homework, because the answer wouldn't come out correct.
Yeah, if you use the wrong table, it will give you, and if you don't use that table the way if you use the method that for this table, for that particular table, it will give you the wrong answer. Now, if you're using to use that table, that means you have to know how to use it, learn how to use it. But if you're using this one, it will give you, and even for that same question, as long as you use this one, follow the instruction on that I gave, and I can show you the screen. I think I have it. I also uploaded the chart for you, so that when you draw, first of all, you have to draw your chart. From that chart, you can then know whether to add to point or to subtract from 0.5. So let me see if I can put that chart for you. It depends on how your chart that you draw looks like. Okay, procedure table. I show you this table, and I also have it in the see, I showed you this table last time. If your chart looks like this, that means you're gonna subtract the area from 0.5. If it looks like this, that means you're gonna add. If it looks like this, you're gonna add. See? So like I said, first of all, draw your chart. Make sure that you read the equation twice, then draw the chart to show what they are saying on the equation. Then you can then know what to do to get your probability or the area. Okay?
Okay.
And usually, like on the questions, they should provide, or it provided us with the table that they use, so we just use the same table.
If you know how to use that table, then use it. But if you know how to use it, but if you, I know that some table for normal distribution are cumulative, so they have a different way of using them. So a slightly different way of using it, because cumulative means that they started from negative side. They start from negative side and go to the positive side. Mine doesn't start from negative. The one we use for this class doesn't start from negative, because negative here means that it's on the left side. That's all. Okay. So give me 1 minute. Just 1 minute. Okay. For example, if you are solving a question like this one here, let's say this way, you're answering this question. It says
We can only see the chart, the pictures that you just put up of the distributions. You can't see.
Solving a question like this one here.
Okay.
Say the milk production of a head of cow is assumed to be normally distributed with a mean of 70 pounds and the standard deviation of 13 pounds. What is the probability that the milk production of a cow chosen at random will lie in the interval 60 pounds to 90 pounds? So in that case, you see what the question says. The probability that it will lie in the interval 60 pounds to 90 pounds. So you gotta transform this using your Z and transform that. Then you can then draw the chart. And then draw a chart. The chart will not tell you what to do. But remember, you have to transform these two numbers using Z equals X minus mean, X minus mean divided by standard deviation. Okay. So you have to transform 60 using this formula, then transform 90 using this formula. After that, you can then draw a chart and they say between two of them, which is go this way. Okay. Now you can then, put the X axis and your center line of 0, then your Z1, whatever answer you get from transforming this, which will be your Z1, gonna be here, Z1. What you got from the other side, from transforming 90 using this formula will become your Z2. Okay. Now, and then you can then, if you look at this chart, so Z2. Now, you can then put your line to present both Z values. For this one, for Z1, and this one, for Z2. And then you can shed the area. Say between the two of them. That means you're looking for this area between them. Okay. Okay, and then so this is the area you're looking for between these two. Now you look at the procedure table, what it says. When it is in that form, it looks like this one here. So you look up the Z value from the table and then add them to get the probability you're looking for. Because this chart here looks like just like the one that I just drew. So the question will tell you how to draw the chart. And when you draw the chart, the way it looks, compare it to what you have on the procedure table, and then follow the instructions there to get your area for Z2Z, or if it's 1Z, Okay. Now let me take your attendance, and then I'll see you guys tomorrow. Oops, excuse me. It's not attendance.
How was your weekend, Professor?
Huh?
How was your weekend?
Weekend was rough, busy, very busy. How about yours?
I would say the same thing, because all your work and my other class. But other than that, it's pretty okay.
Yeah, my own is very rough. I was walking all through. All right, let's see. I heard your voice, so I know you are here with Miss Bista.
Mm-hmm.
So, the John is here.
Have a good day, everyone.
You too. Dog is here.
All right, bye-bye.
Dog is here.
I'm
Shannon. Kishan.
Have a good one.
You too. Walker. I saw Walker.
I'm here. Have a good one.
Somebody's singing. Who is singing? Baby.
My son.
Okay. Socket. Who else? Debbie. I think I marked Debbie. Okay. Kent. Vanessa. Who else? I think I have everyone.
She said she's here.
Huh?
Vanessa said she was here.
Yeah,
On
so
the chat.
I've marked her present. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's make it 11. All right, okay, I'm the one to make it 11. All right, I see you guys tomorrow.
All right. Thank you.